Let's look at another example of solving a system of nonlinear equations. So how about this one? First of all, you should recognize what these equations are. So this first one looks like it's an ellipse. It's an ellipse whose major radius is 3 and minor radius is 2, so something like that. It's not the best ellipse drawing ever. And this parabola looks like it opens downwards and it's shifted up 4, so it goes something like this. So we can expect to find 4 intersection points. All right, so with that in mind, let's see what we can do. Now there are a couple ways to go about this. This second equation is already solved for y, so we could just immediately plug that into the first equation. That is a totally fine way to do it, but doing that would give us a degree 4 equation, which maybe would make you hesitate a little bit. In this particular example, that would work out, but I want to show you another trick. Another thing we can do is, the only place that x shows up in this second equation is right here as x squared, so we could actually solve this equation for x squared. We get x squared is 4 minus y, and then we could plug that into this equation up here. And that's going to give us a degree 2 equation in y, which seems nicer because we know how to solve degree 2 equations. So let's do that. Before I do that, I'm going to actually take this second equation and multiply by 36. I'm doing that to get rid of these fractions, right? The least common multiple of 9 and 4 is 36. So multiplying this equation by 36 gives us 4x squared plus 9y squared equals 36. Now let's plug in this value for y squared. We get x squared. We get 4 times 4 minus y plus 9y squared equals 36. So this is 16 minus 4y plus 9y squared equals 36. So 9y squared minus 4y minus 20 equals 0. I think right. Subtract 36 from both sides. Yeah. Okay. So we can try to factor this one, but I don't think it factors. So let's use the quadratic formula. We get y equals 4 plus or minus the square root of 16 minus 4 times 9 times 20. Sorry, 4 times 9 times negative 20. Okay, all over 18. So 4 plus or minus the square root of 16 plus, oh boy, 80 times 9, 720. Is that right? I think so. So inside this square root we have 736 all over 18. And you know, 736, I doubt it's a perfect square. I don't remember my perfect squares that high, so 736, take the square root of that. Probably not a perfect square. No, definitely not a perfect square. But it might have some perfect square powers. So is it divisible by 4? Yes. So 4 plus or minus, right? Since this has a factor of 4, we can move that factor of 4 outside the square root. It becomes a factor of 2. And the stuff left inside is 184. Let's see, is 184 divisible by 4? It is, actually. So we can pull out another factor of 4, and when it comes outside of the square root, it turns into a 2. So now we have 2 times 2, so 4 up here, times the square root of 46. And 46 is divisible by 2, but not by 4. It's 2 times 23. 23 is prime, so we can't simplify this square root anymore. So over 18. So now we can simplify the fraction. We get 2 plus or minus 2 root 46 over 9. Okay, so these are our y values. We got 2 y values. Now if you look at our quick sketch, that looks about right. We should have, at each of these y values, there should be 2 points. So that means that each y should give us 2 x's. And that makes sense because remember we need to come back and find our x values using this second equation, but every time we put a y over here we're going to have to take a square root to get x, so that square root will produce 2 x values. Alright, so remember our equation is y is minus x squared plus 4, and our first possibility for y is 2 plus 2 root 46 over 9. Okay. So set that equal to minus x squared plus 4. Subtract 4 from both sides. Let's see. 4 is 36 ninths. So 2 minus 36 negative 34 plus 2 root 46 over 9. So that's minus x squared. So flip our signs to get rid of the minus sign on the right. And now we can take square roots. So x is plus or minus the square root of 34 minus 2 root 46 over 9. And then if we want to, we can simplify the denominator. So square root 34 minus 2 root 46 over 3. Okay, so this gives us 2 intersection points. What do we start with, right? 2 plus 2 root 46. Sorry, this is the y value. 2 plus 2 root 46 over 9. Yes, 9. Okay, and then the x, we get 2 x values that go with this y value, plus or minus square root of 34 minus 2 root 46. Okay, over 3. All right. Now for our, so this is 2 intersection points. For our other y value, we have to do this whole mess again. So our other y value was 2 minus 2 root 46 over 9. Set that equal to negative x squared plus 4. So again, subtract 4 from both sides. 34 minus 2 root 46 over 9 equals negative x squared. Flip our signs, take square root. We get x is plus or minus the square root of 34 plus 2 root 46 over 3. Okay, so this gives us plus or minus root 34 plus 2 root 46 over 3, comma, 2 minus 2 root 46 over 9. Okay, so you can see, I mean, this system that we started with wasn't that bad, right? Each equation was only quadratic, right? Only had second powers of the variables, but the solutions that we end up with are pretty messy. So you can imagine that if the equations that we're working with get even a little more complicated, getting exact solutions for the system is going to be quite difficult. And in general, it's pretty easy to write down a system of equations that is essentially impossible to solve exactly. So, you know, in general, you might have to resort to numerical techniques to find solutions. But for these lower degree examples, degree 1 and degree 2 equations that are polynomials, we can find exact solutions if we just try hard enough.